Hi, I'm Teacher Thomas. Welcome to A-Level Maths. This is 9231 Further Probability and Statistics, Topic 4, Non-Parametric Tests, looking at single sample Wilcoxon signed ranked tests. We can use this methodology when we meet 3 assumptions, or when we accept 3 assumptions. Data is symmetric, continuous, and independent. In this test, we're going to compare measurements to a potential median and evaluate the algorithm. Is 6 steps. 1, identify the null and alternative hypotheses. 2, we want to rank our measurements by magnitude or absolute value. Of difference from the proposed median. 3, add positives and negatives. In step 2, we're ranking by magnitude, so we're looking at absolute value, but we need to track whether those differences relate to above or below measurements relative to the median, and we'll add based on those groupings. 4, we identify the test statistic, which is the minimum of the sum of the positive differences and the sum of the negative differences. 5, look up the critical value. And 6, evaluate if the test statistic is greater than the critical value, accept. Otherwise, if the test statistic is less than the critical value, reject. And we're accepting or rejecting the null hypothesis. Let's now look at an example. I want to test using a 5% significance letter whether median is greater than 1.8 kilograms based on a group of measurements. Step 1, my hypotheses. Null median is 1.8 kilograms. Alternative median is greater than 1.8 kilograms. Other scenarios could be less than or not equal to. Now I'll bring in my data, and I'm going to use the data to, step 2, rank by magnitude of difference from the median. These are the magnitudes, and recall or be clear that these are coming from 1.8 minus each weight, taking the absolute value of those differences. Now to find my test statistic, I also need to keep track of my signs. So I'm going to set a column and identify whether the measure is less than or greater than the median. So going down, less than, greater 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 than. All of those are based on comparing the weight to the median. Now I want to identify which magnitude values relate to positive differences and which relate to negative differences. I'm writing the ranking in those columns. So starting from the smallest magnitude, 0.1 down at the very bottom, that has a ranking of 1. Which column does the 1 go in? That has a positive sign. That was a measurement greater than the median. So in the positive column, the ranking of 1 will appear. Scanning, I see the next magnitude going from small to large, 0.2 at the top. That has a sign of negative, so I'm going to put the ranking of negative of 2 in the negative column. Maybe I'll cross these off as I go to make it easier to spot what's remaining and evaluate. Next is 3. Sign is positive. Put a 3 in the positive column. There's a 4. That's a positive. Put a 4 in the positive column. 5 is positive. 5 in the positive column. Next, 6. 6 is positive, goes into the positive column. Next, 0.7 is the 7th ranking. We seem to be hitting a strange pattern here, which is the magnitude of 0.6 was the 6th ranking. The magnitude of 0.7 was the 7th ranking. That's a coincidence. So I'm simply going from small to large in magnitude. It happens to be that that puts 0.7 into the 7 spot. The sign is negative. Put that 7 into the negative column. Next is, again with this pattern, 0.8. So the 8th spot, sign is positive. Put an 8 in the positive column. Then 0.9, positive. Put 9 for the 9th ranking in the positive column. And 1 remaining, 1.1, here we go, we break the pattern. So 1.1, that's the 10th ranked item. So I'm going to use the number 10. The sign is positive, so that 10 goes into the positive column. Now, finishing step 3, I want to add these values. When I add the positive column, I get 46. When I add the negative column, I get 9. And the smaller of these two numbers, the 9, is the test statistic we choose in step 4, the minimum of the total of the positive rankings and the total of the negative rankings. Before proceeding, let's look at what we have and think about what it's telling us. If you look at the number of positive and the number of negative, there are quite a few more positive, greater than the median, than negative. So that seems to be saying that the median might be a little too low. That's producing a small minimum between 46 and 9. If we had a more even distribution of positives and negatives, then the smaller of the column totals would be bigger. So it seems to be, it is in fact, that the smaller the minimum column total, the more likely it is that the data doesn't fit to the proposed median. So the smaller that minimum, our 9 in this case, the more likely it is that that median we're ultimately going to reject. So let's continue, see what happens in step 5, looking up the critical value. Here's the critical values table. Note this is for the Wilcoxon sign to rank test, not the Wilcoxon rank sum test. That's a different table. Let me bring over at the top. The result of step 4 was identifying the test statistic as 9. Now from the table we want to identify our n, and we want to identify our significance. N is the number of measurements we're evaluating, which is 10. The significance, we were given 5%. And so in the table, n equals 10. Level of significance 0.05. This is one-tailed. One-tailed because we're evaluating for greater than. And that gets us to critical value of 10. Now we compare the test statistic of 9 is less than the critical value of 10. This results in a decision to reject the null hypothesis. And this is in line with what we were expecting, that 9 is relatively small because we had a lot of positives, not many negatives. Small relative to what? Relative to this threshold measurement that we've identified as 10. The test statistic is smaller than the threshold measurement. That leads us to reject the null hypothesis. So here I will state reject the null hypothesis. Median is greater than 1.8 kilograms. And this concludes the lesson on single sample Wilcoxon signed rank test.